Okay, we're on the first example of finding the exact values using double angle formulas. So sometimes you're given information on, so this is the challenging part for students, is that you're given information on a single angle measure theta being equal to 3/5. So similar to the problems that we saw in the previous chapter where you have the location of where theta is, you have a description of sine of theta being 3/5. So we know from, and we could deduce that between pi over 2 to pi, that's going to be in, pi over 2 is on top of the y-axis, and then pi is on the negative side of the x-axis. So your angle is somewhere in the second quadrant. And then also we know sine of theta is the same thing as y over r. So we have our y, we have our r. The same process of finding, you're going to find your missing variable, in this case it's x, using x squared plus y squared equals r squared. Okay, so let's go ahead and sketch that in a bigger quadrant. So we have here that my y coordinate is 3, my radius is 5, and then we're trying to figure out our x value using Pythagorean theorem, or we know it's a 3, 4, 5 triangle. However, in the second quadrant, our y coordinate is positive and our x coordinate should be negative, so -4 is our x. And so we come back to what the actual question is. So all of that I was able to glean from just the given information. And then I come back and I realize, okay, well now they want me to find sine of double theta, or 2 times theta, or double angle formula. So what we do is we copy down our double angle formula from above, and we see that it breaks it down so that it's referring to just a single theta. So 2 times sine of theta, now we reference our triangle for this. Sine of theta is equal to opposite over hypotenuse, or y over r, or 3/5, what was given to us at the start. Our cosine of theta would be -4, or x, over r, which is 5. And we simplify that out, we get -24 on top, over 25. For cosine of 2 theta, you have 3 different formulas you can pick from. So it's up to you which formula you want to work with, but in which case all 3 of those will yield the same answer. So I'm going to, it really is up to you, but if you have just a single trig function that you had to deal with, like the cosine of 2 theta equals 2 cosine squared of theta, it means that you only need to find cosine of theta and square it, versus having to find cosine and sine on the first one, and then having to square each one of those. So I'm going to pick either the second or third usually to work with. So 2 cosine squared of theta, and I remember it as, if it's cosine of, it's the double angle formula for cosine, so it's 2 times cosine squared of theta that comes first, as opposed to the third formula, which has sine squared of theta, and that comes at the end. So 2 cosine squared of theta minus 1. So if I take my cosine of theta, again, it's the same premise. So we're going to have cosine of theta being -4/5. And we're going to square that value and then times it by 2 and then subtract 1. So when I square it, I get positive 16 over positive 25 minus 1. 2 times 16 is 32 over 25. And if I subtract 1 and make it a common denominator, I'm going to make it 25 over 25. Or in other words, 7/25 would be my answer.